Hello, everyone. Welcome to a live dev mentoring session. In those sessions, we help students of the iOS Lead Essentials program to solve any software development problems they are facing. Today, we're helping our student, John. Hello, John.
Hi, Caio. Hi,
Thank you,
everybody.
thank you for joining us. Also here with us, Bogdan and Mike, instructors in the academy as well.
Yeah. Hello, everyone.
Hello.
And John, for how long have you been an iOS developer?
I started in 2016, so
Okay.
it's been like more than 6 years.
Cool. Were you doing software development before that?
No, I was a project manager also in digital, but I wasn't now.
Right. Okay, and today you brought us a project where you have some chained closure callbacks and you're looking for a solution, right?
Yes, that's it.
Cool. Let's have a look at the project. So you have a class called Glory.
Yeah.
And what does it do? It connects with some external devices.
Yes, that's it. This is the class who that handle the connection with the device, and to do this connection, the application should have to make many verifications. That is why there are all the call method the callback methods, but every next method needs the completion result to go on. So that is why I nested all the method. I know there is not the best way to do it, but right now it working it works.
Right.
So that's okay, but I'm sure that we can do.
Better.
Right. So
yeah.
you have a lot
Yes.
of async
Yeah.
operations and they need to happen in order. First, you need to get the first async result so you can call the second one. And when you get the result of the second one, you start the third one, right? So
Exactly. But first, yeah, we have to get the session ID, then occupy, do the inventory, etc. Start server, etc. etc. etc.
right. So it's in order. Then you start a server, adjust the time, release the machine, and so on, and close the session. Okay. Cool. And then you end up with this massive chained closures. Let me have a look at it with smaller font. Yeah, this is, if you check the clean code book, they call it the arrow code anti-pattern. It looks like an arrow, right? Like this. Because it's very hard to read this code, right? When you...
And to debug.
Yeah.
Yeah.
Very hard to make a change here and be sure it's correct. Do you have tests for this code?
No.
Okay. Yeah, because usually refactoring, we call it refactoring when we have tests, right? Backing up. So we change the structure of the code, run the tests. If it's passing, we didn't break anything. But without tests, we don't have guarantee that we didn't break anything. So it's not actually refactoring. It's almost like a rewriting some parts. And we don't have safety with tests. So it's not actually refactoring, but we can still use some refactoring tools to help improve the code to make it more readable because it's really, really hard to follow. Cool. So there are a couple of solutions we can use here. One is extracting the completion handlers into separate functions.
Yeah, that is the thing I did. I did that method, and it works also. I extract all the method and all the completion in separate methods. I did that.
Right. And the other one is async await. If you can support iOS 13 and above,
Yes.
right? Then we can use async await.
Let me check because this is a production code, and I'm not sure that all the client got iOS 13.
Right.
I'm not sure.
The app looks 14.1, but let's see the framework. 12.
Yes.
Yeah.
Okay, so you cannot use async await, but we can show how to support both, and you keep the APIs with completion closure for clients in iOS 12 and below, and we introduce new APIs for clients that are in iOS 13 and above, and you can provide both. And if they can, they use the other APIs.
Right.
Cool. So let's first see how we would do it without async await. So if you support iOS 12, one way of cleaning this code, as you said, you tried already, is to extract the completion blocks into separate functions. At least then things will be more like linear. It won't change a lot. And we can start from the outermost completion closure or the inner one. I like to start from inside. I think it's easier to extract code from inside. So this is the last one, get status, right? It's the last
Yes.
call. Okay. So what we can do here is we select all the code within the completion closure, and we can literally refactor extract method. And we could call it like handle get status result. And we need self.
Yeah.
We're already capturing self inside of the closure, so self dot handle get status result. Cool. Now let's have a look. Xcode already extracted this for us. Does it have all the dependencies it needs? No, it doesn't have the delegate. Let's have a look at this. So there is a delegate that is set as a property as self.delegate, but within this closure, you are actually capturing the parameter that was passed to the function. That's why it's not optional. The property is optional.
Yeah.
So we could do something like this. And the behavior is different.
Yeah.
Because let's think about this. If we call this connect method twice, let's say we call it first and it starts opening the session. And then we call this method before open session was called. It will replace the client, the delegate, and everything. So when you get a call back from occupy, for example, we are now referencing a different client. So we cannot call this method more than once, right? It's a limitation of this API. Otherwise, you get undefined behavior. So it's safer to actually pass the delegate as a property to the result and the result method. So we don't have temporal coupling with replacing the properties. Even the client we could pass as a parameter to avoid issues. But then the behavior will be different because here you are using the self.client property. So what I would have to do to keep the same behavior here is to pass the delegate, which is the output delegate. We pass all the dependencies as parameters to the method. So here we need a delegate. And then we don't need the optional. So we're not using the property, we are using the parameter we receive in the function to keep the same behavior we have right now. Because if we use the property, now the behavior is different because if you call this method twice in between the async calls, you get a different delegate, and then it would be weird. You can get undefined behavior if you have different classes implementing the delegate. Okay. So this is the first one. Now, which one is the one before is close session.
Close session.
So let's follow the same pattern. Extract method. So handle close session result. We need the session ID here. Yeah. We need a session ID as a parameter and the delegate as well. Let me copy this here. Now I'm not defining property parameter names here because those are private helpers within the class. So just to make it shorter. Session ID string. We have everything we need now. The session ID. Ideally, Xcode should do that for us when we extract method, but
One day, maybe.
okay. So let's pass here. Delegate and session ID.
And self.
Where?
Oh, before the handle. Yeah, self-dot handle.
Yes. Cool. Well, it's already better. Less nesting. The next one is the release machine. Let's extract. Whoops. Select refactor extract method. Handle release machine result. Need to pass it.
Delegate session ID.
Same, and let's pass the parameters here. Okay, we build.
I think you did a mistake. No? Okay.
Off. Oh, it's building.
Okay.
Just a couple more. Adjust time.
Okay.
Handle adjust time.
Result.
Self. Okay. Now we have like very small functions that are easy to follow.
Mm-mm.
And that's the process. Just keep extracting the methods until everything is flatter. So the next one is start server. So start server, we're not calling on the client, we're calling on the class itself. Start to see some duplication in the handling of the errors. Maybe we can create an abstraction for it. Although sometimes it completes with a different error.
Mm-mm.
Okay. Cool. Okay, much better. We can increase the font again. Inventory. Handle inventory result. There's a call to the delegate here. Cool. And this is the last one. Occupy. Handle occupy result. Get session ID. Cool. Self.
Yeah.
All right. That's it. We can also extract this if you want. No open session. and the open session result. And that's all.
You need
We're gonna need a
delegate.
delegate. Yeah. Because of the error. Cool. Look at that. Compare before and after. Well, you cannot even see it here. Maybe if we lower the font. Yeah, now it's much flatter than before.
Fantastic.
So you tried this solution, right?
Yeah,
Are you
I
happy
already,
with it or not?
I think we can increase this. Maybe with dispatch group.
Could create some kind of semaphores and stuff to try to make things more serial as well. But I don't mind if I'm using like older iOS versions to just have like handler functions, because you can look them independently, right? What do you guys think? Bogdan, Mike, would you use dispatch groups here? Dispatch
I think they're going to introduce
semaphores?
more complexity. Yeah, definitely not.
Because we
Semaphores.
have to enter the group, leave the group, enter the group, leave the group, and
yes, you're going to have to deal with closures. I think so at some point as well.
yes.
So
since all these API calls are sequential, there's no benefit in adding those semaphores. There's no parallelism we can introduce. So we might as well just do it as it is now, with chaining concrete operations one after the other, as opposed to introducing more logic for running the exact same execution flow. So
yeah, because now we don't have a reading problem, right? You can read the code easily. But I want to show now the async await solution, because I think it's better than dispatch groups. So I think I'm going to stash these changes. Okay, we're back here. And now let's create a solution with async await. So all those APIs are defined in a protocol, no, in the client. Are those protocol methods?
yeah, it's actually the client delegate protocol.
Okay, open session, occupy, inventory, just time, release machine. Yeah. So what we can do is create async, like the versions of these methods. So we keep those ones for clients that cannot use iOS 13 and above, but we can create a version of this method, for example, that uses async await. So the completion handler here returns a result of either success with the occupy status or an error. So this is the result type here, right? And representing it in async await, you literally return the success case. You mark it as throwing. There's an error, you will throw. And if it's successful, you will return the success result. And we don't have a completion handler anymore. and we mark it as async. And the implementation will call the old method, occupy session ID, with the completion, with the result. So this method will call the old one and bridge with the concurrency feature. As you can see, because you support iOS 12, still in the framework, Xcode already tells you that you need to add the available attribute. Boom. So only people on iOS 13 above can use this method. Otherwise, they use the old one. I think that is a solution for you. And now we need to bridge into the async await world. We can use a checked throwing continuation because it can fail. You put your method here. When there is a result, you resume with the result. That's it. No more completion blocks here. We can do exactly the same. All those methods. Release machine. What does it return? Occupy use case. What does it return?
Occupy use cases.
Occupy status as well. Okay, so it's the same return.
Yeah.
Cool. Now the next one. We use closed session. I think so.
Yeah.
It's the same. Yeah.
Same return. Okay. We don't use reset, I think, there. So but implemented, close cover exit. We don't. Open session, yes.
Yeah.
And it returns a string, the session ID, right?
Yeah, it's a string, yeah.
And actually you pass a user here.
Cool. Yeah, it's user.
User is session ID. Yeah.
Pair programming is good. Inventory with session ID. Yeah. We use unregistered events? I don't think so.
Register event, yes, we did. Unregister, yeah, register. Yeah.
It's just called from the start server.
Okay. So unregistered events. Session ID. What is the return?
Status. Yes, and it was the status.
Cool. Oh, build failed.
Money item, battery. Oh. It's not a string, it's an array of
money items.
Yeah.
Right. At all? Or we have more adjust time? Yeah.
I think the good thing here is that the compiler is checking those types for us. So
for sure,
it's really easy to do it.
If everything is a string, then we don't have a lot of safety. But if you have typed results, it's very safe.
It's not an unregister even status. The return, I think, is
adjust
time status.
Cool. The compiler let us know here as well. Very nice. Get status as well?
Yes.
It was the last one. And it returns
status
machine
status.
That is too helpful. Look at that. It tells you exactly the type. Change cancel and change we don't need.
it's not in the connect. Yeah.
Cool. Okay, so we have a async await version of it for all the functions we need. Now we can create an async version of this method. You can copy it all here and async throws. Yes. Now we're going to use the new APIs. So open session, it returns a session ID. So session ID equals try await open session. Open session is a function here.
Yeah.
What does it do? Oh, we just call
calls
this.
the client.
I'm going to inline it. It's the same as doing this, right?
Yeah.
So we can now just call client.openSession. We have a reference to the client here. Where is it? Client.
Yeah.
It doesn't need to be optional. I think we can just make it a let and say self.client equals client. Open session for user. Cool. So we got the ID. And if it throws, what should happen if it fails? If it fails, let's see the last thing that happens. Because that's the problem with the current solution is when you call, you get the result here of the first request, the failure case is the last thing you see, right? So you keep jumping around in the function.
Yeah.
So failure, we should, how did I get?
Connection.
The connection did fail. Okay.
Yeah.
So we could use a do catch. If there's an error, we complete with the error. Oh, and of course it's only available. So this method can only be used in iOS 13 and above. Cool, the first one is done. Now, after we have the ID, we need to occupy the session, and that returns occupied.
And excuse me, but where the error come from in line 150?
It tries to open the session.
Yes.
And if that fails, it throws an error, and then we catch the error here.
Okay, yeah, all right.
Okay. It's implied, the error.
Okay, this is implicit. Okay.
Yes.
Because we are completing with a result, and the continuation internally will check if the result is of type failure, is the case failure, it will throw. Otherwise, it will return the value because it's a throwing function. So if the result contains a failure, it will throw.
Okay.
Now the second one, occupy, which returns the occupy status. Try await client.occupy session ID. So we got the session ID first, then try to occupy that session. Okay. And if it fails, what happens? What is the
same thing? Same thing.
Same thing. Okay. So I'm going to delete this
too.
So it's actually very nice that we have a single catch.
Yeah. Wow.
And avoid the code.
All the duplication goes away. But we need to be careful because in some scenarios here, I saw that some errors are of different types.
Yeah.
Like here.
Yeah, but I meant like refactoring to merge all the error types, so it won't be a problem.
Okay.
Awesome. So occupy is done. And then there's some logic with that occupy status. So here you check if, and what is the else case?
Is also always the same.
Here, this is the else case, right?
Yeah.
For that if. Oh, and here you change the status code. Okay, let me bring this here. So you have the if occupy, you do something else, you do an error. So if you want, we can replace this error type here. If we want, we can invert this into a guard. So we expect this to be success and or occupy by itself. Else, we can throw this error, which will be caught here. So this error now will be this one that we throw. So we still have one catch case that handles all the errors. We just define the type of the error based on some logic here. Right, so this is gone, and now we can get the money items. Client dot, what is it called? Inventory?
Inventory, yeah.
Try await. If it fails, we get here. And we have the money items. So the failure case is the same.
Yeah.
That's handled. Awesome. Oh, and here we need to send a message to the delegate.
Yeah.
Cool. And then
we start the server.
But start server, we don't have an async version of it. Have more than one start server? Yeah, this is the one with session ID, right? But we can create a version of it. Auto completion closure. What is the return type?
Status. No.
The Boolean.
Boolean.
Okay.
Okay.
Okay. So async throws and returns a Boolean. The success or failure if it worked. Although throwing is already a failure, right? Maybe we don't need a Boolean here. Let's see. So we're going to call start server. Well, with throwing, checked throwing continuation.
Try.
Yeah. Try. I'll wait because it can fail, and you also need to wait for the result. Let's mark it as iOS 13 only. Some errors in the file, so it's not indenting correctly. So start server, session ID, session handler. Cool. Now we have an async version of it. And we keep the old one for other clients to use. Okay, let's go back here. Now we start the server. Server status equals start iOS start server with session ID. And if it fails, what do you do? Same.
Yes, but is there a logic? Because you need the result is a Boolean. No logic success. Okay.
Yeah, it's ignoring that Boolean.
Okay.
So maybe we don't need a Boolean. Let's ignore it. Okay. If it fails, it will throw probably, right? So you don't need to check the Boolean. Cool. Back here. We don't need this. We just start the server. And if there's an error, it will throw. And we get here and notify the delegate. So this is done. Success case. And now we adjust time. And this returns adjust time status. Cool. Client dot adjust time session ID. And there is some logic with the time. If success, else, what happens in the else case?
Same. No, yeah, adjust time error.
Okay, let's bring it here. turn into a guard, and throw the error. Much simpler. And that's it. Now we release the machine, which returns an occupy status, but we already have a, can I call it something else?
This is yeah, but this is another occupy status. This is a new one.
It's like release the occupy state or something
Yes.
like that.
Try await client dot release machine
Session ID.
session ID. Now there is some logic as well.
Success or occupy by itself.
Let's turn into a guard and throw whatever error this was generating.
Is connection, did it fail? No. I think it's the same. Yeah.
This
You
one,
don't
release
you don't
error.
need release error. Yeah, that's okay. So it's another one.
Release error. Cool. Almost there.
Close session.
So close session. Oh, and by the way, there was a mistake here. What's the wrong
Yeah.
status?
Nice catch.
That's why we need tests.
Exactly. These are things that like you're never gonna find this, you know. Yeah.
Okay. Same logic here. Into a guard. And we need to throw occupy status error.
Yeah.
Almost there. Last one.
Get status.
All right. There we are. Can we build? Build succeeded. Now that's simpler to follow, right? It feels very linear, like normal sync code. Try to open the session, and then you get an ID, and then you occupy the session ID. You check if it succeeded. Then you get the inventory, notify the delegate, start the server, adjust the time. If there was a problem, you throw an error. Then release the machine. If there was a problem, release error, close the session, and get the status, and you're done.
So readable.
I like it.
Yeah.
It's better. If we compare with this, so from the nested closures, that one of the biggest problems is like the success case in here, and then to see the failure case, you need to jump to the bottom of the file. Keep jumping up and down, up and down. Now it's linear, and you can still keep the old version there. You can use the other solution we showed, right, to extract the results for the old version. And as soon as all your clients migrated to iOS 13, you can delete the old ones. And that's the power of the Swift concurrency model. It's pretty good. It helps a lot with making sure things are correct. Because there was probably a lot of problems here with using the self.client, as we said. If we call this method twice before you finish the result, you will get undefined behavior. You will get a new client in the middle of the requests here, a new delegate in the middle of the requests, maybe a new user as well. Now everything is contained here. We're not using self, right? So you can call this method as many times as you want concurrently and not have issues. I guess you don't even need to have properties here anymore because everything is contained in this method. I have access to everything here.
Yeah, that's probably what was limiting the concurrency calls, is having these instance variables. So if you run that multiple times, like this connect operation, you probably, I don't know, hit some race condition when you set the client or the delegate. If you do it like this, like the current version, there's no accessing some shared state. Each call has its own stack version of the client, so it's much safer this way.
I think that's an improvement. So you can start introducing these new APIs for your clients.
Yeah.
Do you have any questions about this solution?
No, it was
Pretty straightforward, right?
Yeah.
And easy to test as well, right?
Yeah.
I mean, both can be testable, right? You need to test it. Your homework is to write some tests for this.
Yeah, for sure. Don't try to like replace the whole thing all at once, because you cannot guarantee the behavior right now, right? So that's why
They
this
behave
is not-
differently. Yes.
Yes.
That's why we don't
So-
call it refactoring, because
Exactly.
refactoring is keeping exactly the same behavior, but with a different structure. We're just changing the structure, not the behavior, right?
And that's the difference. If you have a very good test suite backing up your code, like you can change something, and at any given time you can see if it's green and the behavior remained the same. That's why it's so important to have one. So yes, step by step here.
I see a question in the chat here. Should the with checked throwing continuation be using weak self? Let's have a look. Where do we use it? Here, for example. It doesn't need to use self. We don't even have to type self here, weak self, because it's not escaping, right? It's not an escaping closure. So we don't need to weakify self here, because this will only return when it's done. So there is no memory problem here. It will retain self while this is running until it returns. Make sense?
Yeah, I think that's very important to mention that, because we do use self implicitly on when we call open session, but it's right at the beginning of the method. So that's not a problem. Usually the problem is when it's in the completion. But here
like
we
inside
don't
a completion block. But this is actually the bridging of async await, and this is not escaping. This closure here is not escaping. This one is. If it was inside of this one, it would be a problem. But here, this closure is not escaping. It will retain self. And if it was escaping, the compiler would complain that we are not using self explicitly. For example, here we have an escaping closure, and we are accessing this data parser. If we don't use self, compiler should complain. See? That we're referencing data parser that need to use self explicitly to say, I am capturing self in this context. Here, the compiler doesn't complain. Why? Because it's not escaping closure. That's why you don't need unknown self or weakify self. But write some tests as well to make sure there's no memory leaks.
Yeah.
Why not? Better to be safe. All right, I think that's it. If you don't have any other questions, I think that's a nice solution you can introduce in your code base.
Yeah, really nice.
Yeah, awesome. Do you have any other questions, John?
No, it's perfect.
Awesome.
Many
All right.
thanks.
Thank you
Can
for
I-
joining us.
Yeah, can I add something? So
Yeah, of
that's-
course.
Yeah.
Okay, so if for testability discussion, just if you're kind enough to scroll to the top of the class, just want to make some mentions here. As you're trying to test this class, you'll see that it's a bit difficult because there are some concrete instantiations which make testing a bit complicated. So for instance, you're on the older method, you used to create a client, and in this one too, on line 138, you create a client. So this is a concrete type, and it's very hard to assert the behavior because you cannot replace that with a test double. So you have to extract, like there's a technique to maybe extract an interface out of this. And
There's an interface already
yeah.
we could use,
exactly,
which is
that's
this
the one.
delegate, right?
Yeah. And that's
Right.
also a bit confusing if you got there, because you usually don't expect a class to implement a delegate, its delegate protocol. So a Glory client delegate should be implemented by a different instance, not by the Glory client, which is the case here. So that makes it a bit confusing, because you expect the delegate to be another object, not yourself. So it should be, I don't know, Glory client interface or something like that.
Yeah, we probably would call this some kind of like whatever it does, right? So this is whatever, like a device client, and the Glory client implements the device client.
Yeah.
It's just a naming thing.
Yeah.
It's just user delegate is something like the client will tell another class to do something, right? But in this case, it is implementing its own delegate because it's not sending messages to it. You're just creating an abstraction. So we'd probably call it something more generic, like device. Client. Yeah. Which all the operations you can perform on that device, right? And then here, if you don't want to create this client, because this client will actually talk to a device, right? It will create a connection with a server IP. So it'll be hard to test because you're going to have a device responding to your actions. They can be flaky. Other thing you can do is to pass a client here instead of creating internally. You pass it here. And then you already have a client. When you're testing this method, you pass a stub, a spy, some kind of test double. Then we can have a mentoring session about testing this method as well. If you have any questions about it.
But like, of course, as progressing in the program, we're going to see how, like how to use these techniques, all kinds of dependency injection techniques, and, testing wires, creating all different test doubles and all that. So, yeah, check out the program again. Like, all those things will be very clear.
What do you guys think about this method being super long? I don't see a big problem because things that needs to be run sequentially.
Yeah.
Usually we try to have very short methods, like 4 lines of code maximum. But I think in this case, like having separating things into methods may make it more confusing.
Yes, I agree. Because that's the algorithm,
Because short function is a guideline, it's not a rule. Like you need to follow every time. It's a guideline. Try to make it as short as possible. And I think this is a good size for this specific scenario. It's just a complex scenario, right? And keeping everything sequentially probably easier than calling methods. But you could extract. You can have like this could be a method, and then you group. This section is another method. This section is another method, and so on. But I think it's fine in one method here.
Yeah. It's as Mike said, if this is the algorithm you need to implement, then it should be in a single method. Otherwise, it's just you can't understand it. So
yeah.
And it is like that with, I guess this is a lower level implementation. As you get closer to the hardware, you get
Yeah.
these longer chains of
Absolutely.
Yeah.
At the
messages.
boundary. Yeah.
So
Yeah, talking to devices through Bluetooth, like everything can go wrong, can lose connection anytime. So yeah, it's very low level stuff.
It's a testament that it's probably doing the right thing,
Yeah.
More else statements you have there. Yeah.
Cool. All right. So that's it for today. I think we find a nice solution with async await. If you have more questions, you can ask there on Slack and join a new session as well.
Absolutely. Okay.
Okay.
Thank you so much, John.
Thanks. Goodbye.
Bye.
Bye.
Take care.
Bye.
See you.